In this video, we will examine power laws. Let's start with the looking at what a power is. So we say that's a power, and then power has certain components to it. In this case, the 5 would represent the base, whereas the 2 represents the exponent. When you have a number that looks like this, or a power that looks like this, one would think that the -6 is the base, but in this case it's not. The 6 is the base because the 2 only has power of whatever is directly in front of it. And so 6 is the base and 2 is the exponent. The 2 has no power over the negative. If we wish the base to be -6, we need to put it into brackets and group the negative with the 6. All right, so let's take a look at some basic power questions. Let's consider having 3 squared. We know that that's 3 times 3. Well, if we have 3 squared multiplied by 3 to the 4, the rule is when you multiply powers of the same base, we can add their exponents. So if that were true, then this would become 3 to the 2 plus 4, which equals 3 to the 6. Well, let's explore this. 3 squared is 3 times 3. And 3 to the 4 is 3 times 3 times 3 times 3. And all together we have 4 plus another 2. We have 3 to the 6. Just like we had previously applying the rule. Okay, so when we multiply powers of the same base, we can add their exponents. This does not work when the bases are different, multiplied by 3 squared. This does not work. What we need to do in this case is that this is 2 times 2, and this is 3 times 3, so this becomes 4 times 9, which equals 36. And there is no rule when the bases are different. Okay, let's take a look at powers of powers. Occasionally, we have a situation that looks like this. We have 3 squared all to the third. Well, what that means is that the 3 has power over everything in front of it. So it's 3 squared multiplied by 3 squared multiplied by 3 squared. Well, applying the previous rule, when we multiply powers of the same base, and these all have the same base, we can add their exponents. So we end up getting 3 to the 2 plus 2 plus 2 plus 2, 3 to the 6. So how does that work for powers of powers? 3 and 2 have the relationship that if we multiply them, we will get 6. So a shortcut for powers of the same base is when a power, for powers of powers is when we have powers of powers, we can simply multiply their exponents. So this would be 4 to the 15. All right, let's take a look at division of powers. If we have 2 to the 5 divided by 2 to the 4, well, we really have, this is really 32 because it's 2 times 2 times 2 times 2 times 2. And this one really is 16 because it's 2 times 2 times 2 times 2. How many times does 16 go into 32? Well, the answer is twice. Wow. And 2 is really 2 to the 1. If we look at these numbers here, we can actually see how we can get a 1. If we subtract 4 from 5, we get 2 to the 1. Let's try that again. 3 to the third divided by 3 to the 1. The rule says we can take 3 to the 3 minus 1, which is 3 squared. Well, let's check it out. 3 to the third is 3 times 3 times 3. And 3 to the 1 is 3. Well, this will end up giving me 27, and this will end up giving me 3. Hey, 3 goes into 27 9 times, and isn't 3 squared just another way of saying 9? Finally, let's take a look at the power of 0. The rule is that anything to the 0 power is equal to 1. So let's check it out. 5 squared over 5 squared. Our rule is that we can subtract the exponents, but we know that 5 squared is 25, and we know that 5 squared is 25. How many times does 25 go into 25? The answer is 1. Applying the previous rule, we could say that 5 squared over 5 squared could be calculated as 5 to the 2 subtract 2. 2 subtract 2 is 5 to the 0. Well, what's the right answer? 5 to the 0 or 1? They are absolutely the same. So let's recap. 3 to the squared times 3 to the third. When you multiply powers of the same base, we can add their exponents. 3 squared all to the third. When we have powers of powers, we can multiply their exponents. 3 to the 5 divided by 3 to the third. When we divide powers, we can subtract their exponents. And any number to the 0 power equals 1.